If anybody comes in late, they got to sit up in here in the splash zone. All right. If you guys don't know me, I'm Tony with A to Z. I've been doing mostly VI mitigation for the last, 15, 20 years. This was a really cool project. I really liked working on it. As you'll see, part of the ancillary things that were going on made it difficult to get work done on the job site. But let's start at the top, maybe. Okay. So we're going to talk about some design and installation process at a site in central Michigan. There's 3 buildings here we're going to talk about. This one here in the front, this is called Building 16. It's called Building 17, and then here in the back is called the Event Center. It's because architects are great at building beautiful buildings, but they're terrible at naming them. That was the best they could do. 16, 17, and the Event Center. We're going to talk about some things that got presented to my plate when we got started, some maybe not necessarily the best choices before we did anything, and how we kind of overcame them with the owner group to, by the time we got to the end, we came up with actually a pretty good process. Now I'm going to show you some pictures of the installation overall. As you can see here on the left, this is the track. This entire property is built around I wouldn't call it defunct. It was a car manufacturer's private test track. It used to be called the Proving Grounds. It's now called M1 Concourse. And it is a private track where these people store their Bugatti Veyrons and their fancy $1 million supercars to drive around the test track when they get bored of counting money or whatever it is they do. So we got called into this. Just one plug for CC1000. We used it as our design basis for all the different designs we used. It's a pretty good document. It's going to be revised at some point. If you do a lot of new construction work and you believe you are a subject matter expert, they will be looking to take applications to sit on that committee. So if you do a lot of new construction, have a lot of expertise, that might be a good place for you to spend your time volunteering. So here's the site. We're going to focus on 3 buildings here. This is Building 16, Building 17, and then the Event Center here. And you can see here's the track, goes up and down. It's an 80-acre site. Like I said, it housed manufacturing facilities previously all around the car manufacturer industry. The chemical of concern here is TCE for most of the building, toluene for some of it. I'm not going to bore you with the numbers. We're just going to talk about the relative amount of stuff in the soil gas that drove decision making. By the time the people that turned into a private course got it in 2011, all the buildings that had been there had been completely demolished. And then there were 19 buildings put on it total. I think for some reason, memory serves me that when they got done testing a car and they needed to change the oil, this is where they pulled it underneath the trees to drain it. Okay. Talk a little bit about the buildings. Building 16, 27,000 square foot of garage space, sold as 8 individual condominiums. You own them just like you own a condo. They would put their really, really nice fancy cars in there, and then you could buy one of them for somewhere between $350,000 and $500,000. That is a shell of a building. From that, they would spend up to $1 million putting portraits on the wall or whatever else they do to make them a real-life man cave. So Building 16 was the most expensive garages in the entire project, which meant they had the fanciest, most expensive cars. And that plays into the design a little bit as we go along. There's some moderate TCE in the soil. Building 17, it was 28,000 square feet, and it had 40 individual condos, a little smaller. Same deal, you buy the shell, you build it out, you own it, it's your property. It only costs you like $20,000 a year in dues to drive around the track. TCE was non-detect in everything in this site or around this building until the very, very last round of sampling they had to do. So it got thrown in right at the end. There was a hit, and it wasn't even a big one, and they weren't sure what they were going to do, and they wanted to do something, and they couldn't do nothing because Building 16 and the Event Center were already being mitigated, and they were tied into a TIF grant where they basically spent all the money up front, and then they get it reimbursed in tax incentives on the way back. So basically, we want to design the best possible system on the front end for the client to keep the operation, maintenance, and monitoring plan, as simple and inexpensive in the long term, because that is not covered by a grant. And then we got the event center. This is, they just had the auto show there this year in Detroit. It's a really cool building. And for whatever reason, they made it brown and gray. So it took a lot of gumption to make a Cleveland Browns motif building in the middle of Detroit. I wish I had a picture of the skin, but you'll see it in whatever car magazine coming up here soon. So the event center had some moderate TC in the soil. So we got called in after the design had kind of started on building 16. They were at about 60% C&D, which means they knew what they wanted to do with the building. They had their elevation shot. They were pretty much just filling in the details, where the HVAC systems are going to go, those kind of things. One of the things they decided they needed to do was they wanted to dig down 3 feet. They were going to put the vapor mitigation system down here. And then they wanted to spray in their vapor barrier. And then 22 inches of fill sand. And then concrete. So when you buy your place and you decide you don't want the toilets on this side, you want to move them over there, and you got to cut the concrete. When they move their laterals for their plumbing, they're in this 22 inches of sand, and they never mess up the barrier, which in the beginning seemed like a great thing, except they had to take, approximately 81,000 cubic feet for the bargain basement price of about $750,000 to move that dirt, so that they would have enough elevation for us to do what we were going to do. Because they had done this at a previous site, and they'd been told time and time again that repairing this vapor barrier is very expensive to repair a spray-on vapor barrier. It's expensive. It costs a ton of money. And they were locked into they wanted to do that. And they were far enough along in the design that they were starting to excavate out at the site, and it didn't make sense for us to say, you don't want to do that. So we rolled with it. We said, all right, we can make it work. And then down here at the bottom, they were like, oh, by the way, these fancy Bugatti Veyrans and their Huayras, or however you say that, and their Coco Sings, the fancy cars you see on Top Gear, they're in these units. You ain't going in there to do your O&M plan, because you drop a clipboard on them and scratch the paint, that's $50,000, $60,000 to have it fixed. So I don't want you in these buildings at all afterwards. And we're like, sure, why not? We can do that. So we had to come up with a plan that would make that work as well. So it doesn't look that deep here while you're looking at it in these pictures. So here's our matting, and then there's one of our extraction boxes. We decided we wanted to go with 20-foot grid pattern on our matting, and 6-inch layer of MDOT 6AA. That's just their gravel, the way they call it up there. If you were in Ohio, they call it 57s. Something that doesn't have a lot of fines in it. We ended up with 4 systems with 2 extraction pits, and I'll show you on the overhead here in a minute. We went with a 20 mil EVOH barrier. In this building, we actually taped the seams all the way around. We came up the outside walls, and then we attached the 2 right here in the garage bays. So when they poured the concrete, it's totally disappeared. We ended up using FKD 8s for inline fans on this one, because quite honestly, the one fan we wanted to use was having some technical difficulties and was in the middle of being redesigned in 2018, 2019. So we had to pick these out in a hurry, and given the ability to go to a different fan that's on the market now, we probably would have picked something different. And then great thing about the state of Michigan is they want to make sure you got enough monitoring points in the slab to make sure you got it. So 26 sub-slab monitoring points and 27,000 square feet. That's a lot. Probably a little more than we would have suggested, but because Eagle had to approve the work plan and the design, because if they don't approve it, you don't get the tax credits. So they wanted 26, sure, no problem. You want 100, we'll throw them in there. So now we look on the overhead, and the dark red is our matting, and the triangles are our monitoring points. And here's our excavation, or our extraction pits. And then you can see the 4-inch conveyance piping. 2 fans on this side, 2 fans on this side. All right, pretty simple, standard stuff. You've seen this drawing probably a bunch of times. Next up, monitoring system. So what we ended up doing is we've got a whole bunch of conduit here. There's 3, 4, I don't know, about 2,000 feet of conduit. We got vapor pins in all these monitoring points, and they go from there, the conduit, and they all come back together in a box, just like this on the outside of the building. There's a little service door, and you can open the door and plug your digital right into it, take all your pressure readings without ever having to go inside. So it was a really kind of ingenious solution. We'll get into a little bit of it later, how it works, but not a lot of people tried this. A lot of people tried it and failed, and we were able to make it work. And as a matter of fact, we do something like that on all of our new construction projects now, just because of the long-term O&M cost just goes. So anyway, now you can see over here on the left, that's what it looked like when it was all done. And then when you're doing this much vapor barrier, and it gets to be, 90 degrees during the day, and then you come back in the morning, it's cold. If you didn't leave enough, it's not against the wall in the morning anymore. It's now like a 30-degree angle when it's 60 degrees out, and you got to go back and cut the one side loose and give it a little more play so you've got enough to actually fit the shape that it's going to be in. So, and you can see these are our monitoring points sticking up our 6-inch pipe. Then what happened on the backfill, you don't want this guy to go crazy, crank it up, because he'll tear vapor barriers, he'll tear, pipes, anything you can get near him. So what they did was they dropped a little bit of sand on there, and then this guy would push it over. So he's dropping it on the existing sand, and then this guy just comes along and kind of pushes it out that way as he goes along. And before you ask me why they didn't do it in like 2 or 3 inch lifts and compact, I'll just tell you I'm not the structural engineer, and he said do it like that. But I'm not going to have a problem with the vapor barrier separating from the concrete because I'm a long way from it. So that's a problem for a different person. And once they're all said and done, that's what it looks like. Now the developer spent $750,000, give or take, so that he could bury that vapor barrier and nobody would ever bother it. Anybody want to guess how long it took till somebody bothered it? 1 day. After they do all this sand, MEP's got to come in. They got to put in their plumbing, their electrical, all their undergrounds. The electrician hit it by 9 o'clock the next day. And of course, we left. We're on a different state by then. Here's what it looks like. They sent us a picture going, oops. And then we open it up. Not only were they nice enough to cut the barrier, but they were also nice enough to mix in a lot of sand, make our nice clean gravel not so clean anymore. But we were able to go ahead and clean it up. We sent a crew up there like a week later. We made them wait. And then this is all welded back together, so it's all one piece. So luckily, that was the only time it happened. And it also provided a great time for me to have a conversation with the owner and say, these are condos. We understand that people are going to buy them and sell them. Over the next 30 years, these units, they may change hands 3, 4, 5 times. And out of that, maybe once, maybe twice, they're going to move the undergrounds. So you spend $750,000 just to move dirt. Now, it doesn't count our additional costs to do everything else. When for us to come back in a normal building where they have to move undergrounds and replace the barrier and do a repair like this, it costs you $1,200–1,500. And the beauty of it is, the people doing the build out, it's on them. It's not even on you. And this man thought I had some wisdom when I started talking like that, because he's doing the math in his back of his mind going, well, I could save a whole bunch of money. Why don't we just bring that vapor barrier right on up to the surface? So in the next building, oh, wait a minute. Let's finish up building 16 and we'll go to 17. So here's where we come up the side of the building. When we were done with that, they went ahead and they put steel around it, made it all disappear. Here's the miles of tubing that were coming up underneath the barrier that we had to sort out. And then there was a miscommunication between me and the architect, and this was all the more room he gave us to put everything in. The inside of that square, those are the block lines for the CMU block. So making it all fit, it's like my father would say, it's like an Irishman going to heaven. It's a darn tight squeeze. But we made it. And I mean, it ended up looking really good. I was really tight in there. So I sent an email, I called, I talked to the electrician, I wrote on the building, no electrical. Do not put your electrical box here, because I've got to put my monitoring box right there. So I come back 2 months later to do that, and guess what's right in my road? They didn't even bother to wipe this off. It's still there. So, wasted trip, got to call the electrician, get him back out there, to go ahead and redo it for a third time. So, I don't have those pictures, so they're not in here, but there's the box is just actually sitting there waiting to be installed. And then on the inside, we capped off all our vapor pen monitoring wells with a nice, just a regular wellhead cap. These guys, they had to be rated because they drive their cars over them, and you can't just pick anything. So we had a significant amount of discussion about what that was going to look like, because the question they asked me is, can we put our logo on it? Well, sure. I don't care. Go right ahead. So they wanted to send that out and say, well, how do we take it out and have it machined and all this stuff? And so instead of doing that, like, because we want to keep the weight rating, why don't we just take this and drop it a 1/4 inch, 1/2 inch, and we can put like a 1/2 inch bullet aluminum plate on there, and you can design whatever you want for a CAD system. And they said, great. We'll do that later. Make it the right height, and we'll pay you to come back and lower them when we get that right. No problem. We can do that. I mean, what else are you going to say? No. All right, so building 17, like we talked about. How am I doing on time?
You got like 20.
Oh, I'm good. I'm going to finish early. We have lots of time to sleep. Low potential for VI at this building. This building was actually outside the scope, and when they were doing their last round of sampling, in Michigan, you've got to be 100 feet from the last well that's got any kind of hit on it to be considered okay. This one was at some point in the history like 98 feet from a well that had just a small hit of nothing. And it was a regulatory problem to try to get over this, and what are we going to do? And they decided they were going to test it again, and everything was going to be magically fine, and then they were going to get it taken off the list, and they weren't going to have to mitigate it. And then they get a hit at the monitoring well where the middle of the building is. So they go, uh-oh, now what do we got to do? And it wasn't that high anyway, but we had to put together a plan. How are we going to fix this? Treat it appropriately. It didn't apply for the great reimbursement money because they wanted to build the thing. They didn't want to wait to get applications and all that stuff to go through. So they said, what can we do that's considered reasonable and defendable when it comes to Eagle in Michigan? And I said, nothing. And they said, okay, well, we realize that it's not always the best plan, but let's try something. So we came up with, like I said earlier, we've got the vapor barrier, we pushed it up to the ceiling, or to right underneath the slab. We're using class 2 sand in this one. And then we've got our vent matting. And then where we had the one hit, we took our grid and we kicked it into 10-foot centers. So you're really only 5 foot from the grid that you need for an ROI if you're ever to kick it on. And in the outside, we stayed with the 20-foot on centers and a couple of vent risers, call it a passive system. We didn't put any monitoring system in this long term because apparently, you know, inexpensive cars like Mustangs and Corvettes are in these, so you can damage them if you want while you're there to do O&M if you have to. So the other thing we really worked on was the O&M plan for correctly removing and repairing the vapor barrier. And then one other step we took here is we worked with the plumbing contractor to say, all right, out of all these other buildings here that we've redone and built out, where do they put the plumbing at? Because we can put inverts in that where we think they're going to need everything, and then hopefully they won't have to move anything, and we won't have to worry about messing with the barrier. So the second unit that was bought, they didn't like where they put all the plumbing stuff, so they decided to move it. So they had us come in. After they did everything, we had them cut the barrier in a specific way so it could be easily patched. It was a quick, easy thing, and it turned out really well. And the developer was a little bit disappointed that he had set up building 16 in such a wonderful way to avoid messing with the vapor barrier, and it didn't actually happen. So, and then we have an O&M plan that goes with every property that's required maintenance, or if you're going to be cutting the barrier, this is what you're going to do. If you're going to be putting in a rack to hold up your second car so it can sit on top of your main race car, and you got to put in some anchor bolts, there's language in there to take care of how you put in anchor bolts without damaging the slab, because you don't want to drill all the way through the slab through the barrier. And then a little bit of how we did this one. Like I said, 20-foot grid in the outer third, 10 in the middle. This one only had 2 risers in it. And then this was one of the first, if not the first, projects in the country where we used a 20 mil barrier, but the whole thing was heat welded. So when you're done, we had one gigantic piece of plastic that was as frustrated to tear apart as anything you've ever bought in plastic that's been sonically welded. So it was a cool place to try it. The owner thought it'd be cool to give it the opportunity here. It worked great, and I mean, it's all we do anymore. We don't use tape. Everything we use is heat welded, and it is phenomenal. That's a picture of, see all these extra plumbing lines in the middle that they normally don't put in, but they put them in just in case. And then here's our overhead view, our layout view. You see our 10-foot grid in the middle. The monitoring well that they were getting hits off of was right about here. A couple of risers in the middle, and then the rest of it's just a 20-foot grid. And then we actually put the matting down first, and then they put the sand over top of it. That's a big point of discussion in new construction. How do you create that in elevation? Because if they put the aggregate layer down first, they want you to come back and shovel it all out so that your barrier or your matting is the same height as the bottom of concrete. And then you go, okay, no problem, here's the labor bill for this. And they go, whoa, we don't want to pay for that. We say, all right, well, how about we put it down first? Then you can put your stuff over top of it. And this works the same. You get the same amount of mitigation effort out of it, but this also keeps you out of the wind. Like here, this track was pretty windy, so we had to put that over, nothing wanted to blow away. And here it is being welded, and that's what it looks like when we're done. Several regulators said, where's the tape? There isn't any. So.
Did the manufacturer do that, or did you do that? Heat sealing?
We worked with the manufacturer of the barrier and the manufacturer of the actual equipment to make it work. And they both said so.
And how did you smoke test it?
With a shot vac and a blower for smoke. Yep, I wish I had a picture of it, but yeah, you just get yourself a fog machine and go nuts. Blow it under there and
you pressurize it to the thing?
Well, you don't want to do that. I mean, you don't want to try to pick the barrier up, but you want to put enough, you go 50, 60 feet down, and you cut a hole in it, and you say, all right, well, we got smoke coming out here, so from here to here, if there's any leaks, we'll see it. And then if there are leaks, you go back and you patch them, and then you just keep moving as you go. On the first side, building 16, that smoke test took about 4 hours, and there were some leaks. You expect to see some. On this side, I think they had 2 leaks in the whole thing once we welded it. It was just amazing how much better it was. And your communication once you're done is just phenomenal on this stuff because there's no leaks. All right, so now to the event center. They had also slated in this building to dig down, truck out a whole bunch of soil, except instead of 3 feet down, for whatever reason, they had to go down 11 feet. And I don't remember why, but when I said, how about we just keep that barrier right up against the surface, and they did the math and said, well, we could save this much money. And I said, yeah, you can repair a lot of barrier for $1 million, an awful lot. And they said, come right up, put it right there under the surface. So this one, we got a 20-foot grid, 6 inches of MDOT 6 AA, like the first building again, and then a central monitoring system, like building 16, except we located the panels inside the building because it's their space. They can access it whenever they want. Now, all right, so here's, that's the event center, and then this is the track. And they were running cars around here every day while you're working. So like you would just hear something go, and everybody look up, see what it was, and then you go back to work. So it was kind of cool. And then this barrier here was also welded. We were using 2 Fantech RN4 EC motors installed in line on each system. I've been doing that for a while. I really like it. It gives me the lift that I want, the static pressure and the volume, and they're 5-year warranties on the fan, as opposed to some of the other options. And they're pretty good on energy too. And then this one, it only needed 24 sub-slab monitoring points. So, you know, Eagle went light on us there. There's some pictures from the underground. Here's our aggregate, here's our monitoring locations, and there's our conduit coming in and out of it. Concrete guys only broke these about 3 or 4 times, which was pretty good for them because they were not motivated to get much done. When you're working on site and you're supposed to be working with other contractors, you assume they work the same speed you do. So when you're doing 27,000 square feet to put rock in it, it usually takes about 2 days. These guys took 6. We couldn't get too much further ahead of them because we weren't sure what they were going to do, and then we couldn't start doing vapor barrier on the backside of them because they didn't do it uniformly. They said, let's do this room and then let's do this room. And if we would have started, they would have been driving over our barrier, which would have not been ideal. And every one of our legs has a gate valve, which you can open and close. Luckily on this project, I think there were 9 of them, and they only managed to break 1 during construction, so that was pretty good. Sealing these conduit banks is a giant pain. It doesn't matter how you do it. It's not. It takes somebody with way more patience than I have. Nick did this one. He did a really nice job. Looked pretty. And that's some matting. This went down, and then the aggregate layer goes on top. And here's what that looked like after it went upstairs. And this is it on the roof. And then, see, this is one of the things we got to talk about in the standard. You know, they're trying to change it to 6 feet or 4 feet for horizontal on piping. Well, these trusses are 6.5 feet apart. That doesn't quite get it. It doesn't make a lot of sense to throw like a piece of strut up over them so you can put an additional hanger on it. So that's something we'll have to bring up next meeting.
That's part of the code.
Well, just depends which code. Yeah, it just depends which code you're in what building, like, and what you're using. Yeah, yeah. So, well, they did it to try to harmonize all the codes. Like, one inspector we had that was busted a mitigation system because it wasn't 4 foot like everybody else. It was like, just make that code 4 foot. Well, that works in wood construction, but not in this kind of construction. It very well may be. And then here are stacks up on the roof before the electrician took 2 weeks to get them on. Doesn't matter what you tell them. Like when we do these, it's 3 days from the time these are delivered. If it's not freezing outside, they've got to be up and running or there's no warranty. So when we deliver them, they're on the clock. So if they don't start up, you know, we're not going to show up and play with them. It's either you install them because we're serious, we want to get these things running, or you're not. And another thing we do here, big tip for anybody that does new construction, especially if you're doing active, these go on and are running before the building is balanced by the HVAC contractor. So that way I can say in my report, we're not backdrafting. Because if it was, they would have found it when they balanced the building and they wouldn't have been able to issue the report. If you install these afterwards, you can get yourself in some real sticky situations, because I don't know how many people in this room could go in and try to backdraft test a boiler. Like, I don't know how to do it. Like, it's not something I do. So instead of me trying to make it harder, we just make sure we get the fans on site and up and running before the system's balanced in the whole building. And it makes your report easier because you just pull the paperwork out from the HVAC contractor from, you know, you ask for the general contractor, he sends it to you, put it in your report, you're done. All right. Last thing, central monitoring. So this is what it looked like inside the event center. There's a port for each one of the, on these two, there's a port for each one of the monitoring guys. And then there's a gauge for each one of the fans. So you can walk in there, you can read the pressure without going to the roof. And then,
What size tubing to protect the conduit for the monitoring tubes? Is that half protected?
this is 2-inch.
The
The,
smaller one for the.
the smaller one's only got 1 in it, so it's 3/4. The other two have got more in it, so it just depends. Yeah, so
How did you end them in the gravel?
vapor pins. Yeah. So, and then I get this a lot from people going, oh, you can't use tubing that long. You too much pressure drop. You can't measure it. And it's just factually incorrect. I mean, there's 1 foot on the left, and then this comes out of here and it's a T, and then this is 500-foot roll and another 100-foot roll I had hanging around, or 200-footers, and came up to 700 feet. So, I mean, pressure loss there is what, 5 thousandths? And I imagine if I played with a little more, I could probably get it down to 1 thousandth. But you're not measuring flow in there, you're measuring static pressure, so there shouldn't be much pressure loss over distance. And I mean, we try not to run 700 feet, but we have run 300, 400, 500 feet without any issue at all. And then when you get one of these up and running, this is a different site, but I had a digital, and it's the reason why we use metal enclosures. So when we're doing documentation, I just take our magnetic guy and stick it on there and just take pictures as we go. So this monitoring point 1 was a different stairway in another part of the building. So in order to reference the indoor air there so we can make a proper measurement, there's a second tube that comes over from over there and goes to this indoor airport. So you measure MP1 and this indoor air reference. And then just to make sure that nobody got confused, this indoor air reference is for the rest of them, and it's for the part of the building that we're in. So there's nothing on the back side of this. It's just open to the inside of the box and inside of the building. But that keeps them from getting messed up, because there's about, on this day, I think there's about 8 thousandths difference between being plugged into your indoor air reference for this side and not. So it makes a big difference. And yeah. All right. Questions, comments, concerns, conundrums?
This is all regulated purely on pressure field extension, no requirement to demonstrate the lower concentrations of other.
Well, yes and no, because the design to qualify has to meet a metric of 20 thousandths, right? So we've got to make sure we meet that in all of our monitoring points. And then they also do something ridiculous over there where they want you to shut one system off and make sure the other system still works anyway. It's convoluted and it doesn't make any sense, and it's what they want. So you just over-design the system to work. You end up making it 40 thousandths along where 2 systems meet instead of 20. But it's what they want, and I don't want to argue with them. I've got better things to do. But as long as we make 20 thousandths, now there's still indoor air measurements that the consultant will make. And then once I'm done with the project, when like everybody does it differently, but on these kind of projects, we do the design work. We work with a consultant that does all the regulatory submissions and paperwork, and then it all goes in together. And then at the end of this project, our O&M plan is basically put in their final application for Eagle, and they put a cover letter on it and some stuff about the indoor air results that they had. And then our O&M plan is basically their submission for how the system's operated for going on. So if any of you guys took that Saturday class with Radon Away, they talked about like the differences. Some people can only turn in part of their O&M plan. It might be a page. Ours might be, depending on the site, it might be 200 pages just because of all the stuff that goes in it. And writing them is just all kinds of fun. It's what gets me out of bed in the morning. But anyway, does that answer your question?
Yeah, so there was no regulation on sub-slab concentration.
No.
Requirement to measure sub-slab
Mm-mm.
concentration.
No.
Do you have any change in that?
No.
Because I'm just familiar with Michigan taking the weird position they don't regulate indoor air, and they want to.
They are a head scratcher. Like of all the places we work, they have the most
Convoluted regulation.
original interpretations. Let's just stick with that in public space. How about that? Yeah, it is what it is. But like, if these places would have been like Indiana or Ohio, you'd have had 7, 8, maybe 9 monitoring points at most. But up there, they're like, when you, let me see if I can, they're convinced for whatever reason, and I don't know who taught them this. I got to go back to the screen so I can show you the overhead. Come on. I got a couple minutes left, right? Okay. Come on. Come on, baby. You can do it. Okay. So they're convinced here that in this layout like this, you're more likely to have not enough pressure in the middle of one of these than you are on the outside. And I'm like, that's not really the way it works. But you can have an argument with them until you're blue in the face. They say, if you would like our money, we would like you to do this. And we say, we're coming right up. So on a building like this, like monitoring point 3, 9, and 17, because they split a system, they'll want us to turn these systems off and make sure you measure 20 thousandths coming from this way, and then turn these on and make sure you got 20 thousandths coming from this way with these off. Now, if I did that and I had 19 thousandths coming from here, and then I turned this one on and I had 2 inches coming from this way, it's still considered a fail. They want you to, they said, well, you need to scoot back and put in a new monitoring point so you can show you have 20 thousandths coming from this way. And it doesn't make any sense, because, you know, obviously the system's meant to work together, for one thing. It's not meant to just be, if we only want to run one of the systems today, how's it going to work? That's not necessarily how it goes. So anyway, you got me on my soapbox.
I got one more.
Yep.
First, I'll applaud you for using the indoor reference for your outdoor monitoring box. I'm serious. Most people that are putting in these combination outdoor monitoring boxes
Yeah.
use outside air as their reference.
I was going to not say anything and see if anybody in the audience called me out on it.
So it's good for
Thank you.
The other thing you want to look at is wind load on the building sometimes can be more than 20,000. So by using one reference that are centrally located on one edge or the other can be problematic, especially when you're in the 1 to 4 Pascal range.
Interesting.
So just something to think about when you're putting those references in.
Like the one at the end of the slides, that particular area is only, I don't know, it's the size of a stairwell. So, I mean, I don't know how you're going to get 2 in it. But the other thing we do when we go ahead and commission these systems is we'll take the readings at each one of the monitoring points, and then we'll take them at this and say, all right, we're good because everything's right. And there's been a couple where we've been off by 1 or 2 thousandths, but nothing crazy.
Just heavy wind days is when you got to worry about.
Check. Only do tests on non-windy days. Yeah. Anybody
All right.
else?
Well, in the interest of staying on schedule,
All right, I'm out of here.
you're given the hook. So.
Thanks, guys.